March 12, 1943. Luftwaffe Headquarters, Berlin, Germany. General Major Joseph Kamhuber lifted the intelligence brief with 2 fingers, holding it away from his uniform as if it carried disease. His iron cross glinted under the harsh electric lights as he sneered at the typewritten text. "Look at this," Kamhuber said, dropping the report onto the mahogany table with theatrical contempt. "The Americans claim they're mass-producing cavity magnetrons. Cavity magnetrons? They can barely produce reliable spark plugs." Oberst Hans-Joachim Jabs, commander of NJG-1, nodded with the confidence of 31 night kills. "The British invented radar, and even they can only equip a handful of aircraft. The Americans will be lucky to field a dozen functional units by year's end." Major Werner Strabe, Chief Intelligence Officer for Night Operations, leaned forward with measured concern. "Sir, the intercepts suggest production numbers that seem unprecedented. Perhaps we should reassess their industrial capacity." But Kamhuber waved him off with a bark of laughter. "Assess what? Their industrial capacity? We've seen it. At Schweinfurt, we shot down 60 of their bombers in a single day. At Regensburg, 59 more. Our night fighters achieved a 12-to-1 kill ratio against their pathetic night bombing attempts last month." The Luftwaffe had destroyed 1,047 Allied bombers in the previous 3 months, while losing only 87 fighters. German Liechtenstein BC radar equipped 400 operational night fighters, each with combat-proven success rates. The mathematics were undeniable. German technological superiority combined with tactical excellence created an impenetrable night defense. What Kamhuber didn't know, what none of them could have known as they studied their victory reports in that Berlin headquarters, was that American cavity magnetron production would reach 3,000 units monthly within 8 months, equipping aircraft with radar 10 times more powerful than anything Germany possessed. The numbers would become grotesque. 27,000 American-produced radar sets against Germany's 2,400. American factories would produce 94,000 magnetrons in 1944 alone. German night fighter losses would exceed 70% by war's end. The laughter in that Berlin headquarters would become history's most expensive miscalculation, measured in 3,800 dead Luftwaffe night fighter pilots. At Flensburg, General Major Kamhuber reviewed the previous month's statistics with satisfaction. At the Battle of the Ruhr, German night fighters achieved an 11-to-1 kill ratio. At Hamburg, they shot down 43 RAF bombers in a single night while losing 4 fighters. At Berlin, the ratio reached 15-to-1 as wild assault tactics devastated unescorted bomber streams. Kamhuber's Liechtenstein BC radar, operating at 490 MHz with a maximum range of 4 kilometers, had proven decisively superior to British AI Mark IV sets. The German system used Matratzi antennas providing 60-degree azimuth coverage, while British sets struggled with 30-degree coverage and constant jamming vulnerabilities. Recent American failures confirmed their technical inadequacy. 8 B-17s lost over Wilhelmshaven without a single German fighter destroyed. 12 B-24s shot down over Kiel against 0 Luftwaffe losses. And the disastrous Schweinfurt-Regensburg mission, where American formations suffered 25% losses in daylight. Even their vaunted Norden bomb site, supposedly accurate within 100 feet, routinely missed targets by over 1,000 feet under combat conditions. Oberst Kamhuber had personally flown 87 combat missions, achieving 31 confirmed kills, including 7 heavy bombers. His tactical innovations, the Himmelbit system of ground-controlled intercept boxes, layered defense zones, and coordinated radar fighter cooperation, had created a night defense network the Allies called Kamhuber Line with grudging respect. Each of his 400 operational night fighters represented months of careful training, irreplaceable tactical experience, and technological advantages that seemed insurmountable. German pilots trained for 18 months on average, mastered instrument flying in conditions that grounded Allied pilots, and operated radar equipment requiring university-level technical understanding. The Bf-110G4 night fighters carried Liechtenstein C-1 radar with Matratzi antennas, 2 30mm Mk-108 cannons, 4 20mm FF cannons, and experienced crews who had survived dozens of combats. Major Werner Strabe had been filing increasingly urgent reports for 3 months, each dismissed by Kamhuber and Operational Command. "Sir, Signals Intelligence indicates American radar production reached 400 units monthly in February. By May, intercepts suggest 800 monthly. These numbers suggest mass production on a scale we haven't seen. Strabe presented intercepts from 5 separate sources, production reports captured from a downed B-17, and prisoner interrogations, all indicating unprecedented American industrial mobilization. He calculated that if American claims proved accurate, they would achieve numerical superiority in airborne radar by August 1943, despite entering radar development years behind Germany. But Kamhuber had dismissed each report with the same response. American propaganda. Even if they could produce radar sets, they lacked the trained operators, the tactical doctrine, and the combat experience to employ them effectively. We've been perfecting night fighting since 1940. They're barely beginning. Lieutenant Paul Zorner, flying BF-110 G4WNR. 740,162, had experienced German technological superiority firsthand on 17 missions. On March 3rd, his Liechtenstein radar detected a Halifax bomber at 3.8 kilometers while flying at 6,000 meters over the Ruhr. He closed to 200 meters undetected, fired a 2-second burst from his 30 cannons, and watched the Halifax explode. Elapsed time from detection to kill, 240 seconds. On March 8th, he intercepted a Lancaster attempting to evade by diving and turning. His radar maintained lock through every maneuver. Kill time, 180 seconds. His 17 kills averaged 195 seconds from detection to destruction, demonstrating radar-guided night fighting superiority that British bombers couldn't counter. German crews joked that British bombers might as well carry signal flares announcing their positions. German radar made them equally visible. The mathematics seemed irrefutable. 4-kilometer detection range, 200-meter optimal firing position, 2-second cannon burst duration, and near-certain bomber destruction. The Allies had no answer. Western Electric Hawthorne Works, Cicero, Illinois, April 1943. Margaret Hutchins adjusted the calibration dials on magnetron assembly station 47, while 3 more units moved down the line every 60 seconds. The Hawthorne Works produced 180 cavity magnetrons daily. Every 8 hours, another 60 magnetrons rolled off the line, each containing precision-machined copper cavities accurate to within 0.001 inches, vacuum-sealed quartz envelopes, and resonant frequencies calibrated to exactly 3,000 megahertz. This single facility produced more radar magnetrons monthly than the entire German electronics industry combined, including Telefunken, Siemens, and all military contractors. In January 1943, America produced just 340 cavity magnetrons monthly across all facilities. By March, production reached 890 monthly as Western Electric, Raytheon, and General Electric brought new lines online. By June, the Hawthorne Works alone was producing 5,400 magnetrons monthly, more than Germany's entire 1943 production of 4,200 magnetrons. This single facility was producing more advanced radar components than the entire Third Reich. Margaret Hutchins, previously a seamstress at Hart Schaffner Marx producing men's suits, now operated the magnetron cavity milling machine producing 60 precision copper resonators every 8-hour shift. Her machine, a modified Cincinnati milling machine company Universal Mill adapted for radar work, carved cavities accurate to tolerances German machinists couldn't achieve with hand fitting. Each cavity required exactly 47 seconds of machine time, 12 seconds for rough cut, 28 seconds for precision milling, 7 seconds for dimensional verification. She produced more magnetron cavities in one shift than the entire Telefunken Zehlendorf facility produced in a week. Her station represented American mass production's decisive advantage: standardized processes, interchangeable parts, and production speeds that made craft manufacturing obsolete. German technicians hand-fitted each magnetron cavity, requiring 3 hours per unit and university-trained machinists. Margaret had received 2 weeks of training and produced higher-quality components at 45 times German speeds. Robert Washington, from Gary, Indiana, operated the vacuum sealing station that processed 45 magnetrons every 8-hour shift. His single station's daily output of 135 sealed magnetron tubes exceeded the entire monthly output of Germany's Lawrence AG facility in Berlin-Tempelhof, which produced 118 radar tubes monthly using hand-blown glass envelopes and manual vacuum pumping. Washington's automated system evacuated each magnetron tube to 10-6 torr in 90 seconds, sealed the quartz envelope with precision flame cutting in 45 seconds, and verified vacuum integrity in 30 seconds. Total cycle time 165 seconds per unit. The Lawrence facility required 4 hours per tube using hand pumps and glass-blowing techniques unchanged since 1920. American automation eliminated the craft skills that limited German production, replacing artisan expertise with engineered processes any trained worker could execute. His equipment represented $47,000 in specialized machinery that paid for itself in 3 months through production volume impossible with traditional methods. Charles Wilson, $1-a-year man from General Electric's Schenectady Works, managed the quality control systems that tested every magnetron at full power before shipping. His testing rig processed 180 units daily, subjecting each to 30-second full power operation at 3,000 megahertz while monitoring frequency stability, power output, and thermal characteristics. Units failing specifications, roughly 3% of production, were immediately scrapped and recycled. Americans discarded 5.4 defective magnetrons daily, representing more advanced radar tubes than some German facilities produced in a week. The testing equipment alone, valued at $180,000, exceeded the total capital investment in many German electronics workshops. Wilson had helped design the automated testing systems that made such quality control economically feasible, systems that would have bankrupted German manufacturers attempting similar standards. Americans discarded 840 pounds of copper scrap daily from magnetron production. Germany allocated 180 pounds monthly for all radar tube manufacturing across all facilities. The rejected copper contained trace impurities, 0.03% zinc, 0.02% lead, that made it unsuitable for precision magnetron cavities but perfectly acceptable for German standards. American specifications required 99.95% pure copper. German manufacturers used 99.7% copper and considered it adequate. The discarded material could have built 2,400 German radar sets using their less demanding specifications. But Americans threw it in scrap bins without recording the loss, while German facilities weighed and accounted for every gram of copper, allocating it by Wehrmacht priority code. The waste from single-day magnetron production at Hawthorne Works exceeded Germany's total monthly radar component output measured by unit count. The 5.4 rejected magnetrons represented more functional radar capability than many German night fighter squadrons possessed. Hawthorne Works produced more magnetrons daily than Germany's largest facility produced monthly. Americans operated 3 such plants by June 1943, with 5 more under construction. The mathematics became absurd. 16,200 American magnetrons monthly against Germany's 350. Single American factory production exceeded total German national output by factor of 46. Workers threw away quartz envelopes with microscopic imperfections, tiny bubbles, slight thickness variations, that German technicians would have carefully hand-worked and installed. The Hawthorne Works discarded 47 quartz envelopes daily as substandard. The Telefunken facility hand-blew 43 envelopes monthly and used every one regardless of minor flaws. American quality standards treated as waste what German manufacturers considered acceptable finished product. The rejected envelopes filled a 55-gallon drum weekly. That drum contained more radar tubes than some Luftwaffe wings possessed operationally. The cafeteria at Hawthorne Works discarded more food daily than the Telefunken Zehlendorf facility workers received in monthly rations. Workers left half-eaten sandwiches, partially consumed milk bottles, and unwanted vegetables on their trays. 200 pounds of food waste daily from the 3,000-person magnetron production workforce. The Telefunken facility's 280 workers received 3,800 pounds of food monthly through ration cards, carefully distributed and fully consumed. American workers complained about cafeteria quality while throwing away more protein, calories, and vitamins than German engineers received. The discarded food represented 112,000 calories daily, enough to feed 56 German workers at their standard 2,000-calorie ration. The aluminum scrap from rejected magnetron housings, 18,000 pounds monthly, could have built the entire fuselage structure for 47 Bf-110 night fighters using German aluminum allocation standards. Americans scrapped housings for cosmetic imperfections, small scratches, minor dents, color variations in anodization. The rejected aluminum went to recycling facilities where it was melted, refined, and returned to manufacturing within 3 weeks. German night fighter production allocated 380 pounds of aluminum per airframe and rationed every pound through complex priority systems. The monthly waste from a single magnetron production line exceeded Germany's aluminum allocation for an entire night fighter wing. Major Werner Strabe appeared in the intelligence summary dated May 15, 1943, with production statistics that should have alarmed operational command. American radar magnetron production, 2,800 units monthly. German production, 350 units monthly. Single American facility, Western Electric Hawthorne, producing 5,400 magnetrons monthly, exceeding our entire national output. Enemy production capacity increasing exponentially, not arithmetically. Recommend immediate reassessment of technical and industrial assumptions. The report reached Kamhuber's desk with previous reports, intercepts, and prisoner testimonies all indicating the same conclusion. He filed it with a notation. American propaganda figures. Disregard. The mathematics Strabe presented were accurate. By June 1943, American radar production would exceed German production by factor of 53. May 27, 1943. Over the North Sea, 52 degrees 14 N, 3 degrees 51 E, 23:47 hours. Lieutenant Paul Zorner was conducting routine patrol between grid squares NE-440 and NE-441 when his Liechtenstein radar screen showed something impossible. At 23:47:12, his radar detected an aircraft at 4.2 kilometers, normal range for a heavy bomber. At 23:47:34, the target disappeared from his screen completely despite clear weather and no evasive maneuvers observed. At 23:48:01, his radar showed only static across all frequencies. At 23:48:47, ground control reported losing contact with his transponder. At 23:49:15, his radar suddenly displayed 17 separate targets where one bomber should have been, all at impossible distances and bearings. At 23:49:33, Zorner's radio operator, Feldwebel Klaus Mayer, reported visual contact with a Lancaster bomber at 800 meters, flying straight and level. Zorner closed to 400 meters for positive identification. At 23:50:02, he armed his weapons and prepared to fire. At 23:50:11, his Liechtenstein radar showed the target had moved to his 6 o'clock position, 200 meters behind him, physically impossible given their relative speeds and headings. At 23:50:19, tracer fire passed his canopy from behind. At 23:50:22, cannon rounds struck his port engine. At 23:50:26, his engine caught fire. At 23:50:33, he gave the bailout order. Elapsed time from engagement to destruction, 81 seconds. Kill time, 11 seconds from first enemy fire to aircraft loss. Zorner's Bf-110, which had achieved 17 confirmed kills in 4 months of night operations, was destroyed by an enemy he never saw on his radar, never detected visually until after his aircraft was fatally damaged, and couldn't track with his previously infallible Liechtenstein system. At 23:51:44, Zorner and Mayer parachuted into the North Sea, where German rescue boats recovered them at 01:33. Total engagement duration, 4 minutes 32 seconds from initial detection to bailout. Enemy losses, 0. German losses, 1 Bf-110G4 valued at 450,000 Reichsmarks, 2 experienced crew temporarily out of action, and 1 night fighter mission failure. Kill ratio, 0:1. The ammunition fired in this brief engagement, 17 30 rounds and 43 20 rounds expended by the British aircraft that destroyed Zorner's fighter, exceeded the monthly combat allocation for an entire Luftwaffe training squadron, which received 12 30 rounds and 30 20 rounds monthly for all aircraft combined. Generalmajor Kamhuber reviewed Zorner's after-action report with visible irritation. Equipment malfunction, radar failure under combat stress. Mayer probably saw reflections from clouds and mistook them for tracer fire. Zorner, standing at attention despite his injuries from the North Sea landing, maintained his report's accuracy. Sir, my radar showed 17 false targets. My transponder failed. Ground control lost contact. These are not random malfunctions. They indicate systematic jamming. but Kamhuber's aide, Hauptmann Friedrich Karl Müller, supported the commander's assessment. The British have attempted radar jamming since 1941 with minimal success. Their window chaff is ineffective against our latest frequency sets. Technical malfunction is the only logical explanation. Zorner saluted and left, knowing his report would be filed as equipment failure, operator error probable. But 3 other night fighter crews had reported similar experiences in the past week. Radar showing impossible targets, sudden signal loss, and bomber aircraft that seemed invisible to German radar, while German fighters appeared completely visible to Allied systems. Intelligence dismissed the reports as equipment malfunctions correlated by coincidence. The Telefunken technicians who maintained Liechtenstein radar examined Zorner's damaged unit and found nothing wrong with the components they could test. The fire had destroyed critical circuits, preventing comprehensive analysis. The radar was functioning within specifications before the fire, they reported. No evidence of jamming or Allied countermeasures. The report satisfied Kamhuber, who had 400 night fighters equipped with Liechtenstein radar and couldn't conceive that the British had developed effective countermeasures without German intelligence detecting it. The mathematical impossibility of British radar superiority seemed absolute. Germany had been refining radar since 1935, Britain since 1935, but America had only begun serious radar development in 1940. How could they have leapfrogged 8 years of German research in 3 years? Major Werner Strabe reported to headquarters on June 2, 1943, with intercepts that should have shattered German confidence. Signals intelligence confirms American aircraft carrying AN/APS-10 radar with 10-centimeter wavelength, giving them detection capabilities exceeding our Liechtenstein by factor of 3. British aircraft equipped with H2S navigation radar using cavity magnetron technology we cannot match. Allied electronic warfare assets including mandrel jamming pods and new window chaff, specifically tuned to our radar frequencies. Strabe included technical specifications captured from a downed B-17, photographs from reconnaissance of American radar installations, and testimony from a captured RAF electronics officer who freely discussed Allied radar superiority, confident that Germany couldn't match their production even with full knowledge of the technology. The American production figures Strabe presented seemed impossible. 3,400 airborne radar sets produced in May 1943. German production, 287 sets. A single American contractor, Western Electric, produced more radar systems monthly than Germany's entire electronics industry. They tried increasing Liechtenstein radar power, hoping to burn through jamming. The Americans deployed more powerful jammers. They attempted shifting to new frequencies outside the jamming spectrum. The Americans jammed those frequencies within 2 weeks. They tried deploying Naxos radar detectors to home in on British H2S emissions. British bombers turned off H2S during final approach, eliminating the homing signal. They attempted concentrated fighter formations to overwhelm individual bombers. Allied gunners, guided by radar-directed fire control, engaged multiple fighters simultaneously with accurate defensive fire. June 12, 1943, over Münster, Germany, 01:14 hours. 8 Bf-110 G4 night fighters from NJG-1 intercepted a formation of 37 Lancaster bombers. At 01:14:33, Liechtenstein radar detected the formation at 3.8 kilometers. At 01:15:02, all 8 fighters reported sudden radar loss. At 01:15:47, the formation carpet-bombed Münster without fighter interference. At 01:17:23, ground control restored partial radar contact. At 01:18:01, Hauptmann Werner Bach achieved visual contact with a Lancaster and closed to firing position. At 01:18:19, his aircraft exploded from defensive fire he never saw coming. Kill time from first enemy round to destruction, 4 seconds. At 01:18:56, Lieutenant Hans Kraus reported radar lock on a bomber. At 01:19:04, his aircraft took hits from a bomber he wasn't targeting, firing from 600 meters with impossible accuracy. At 01:19:11, his port engine failed. At 01:19:18, he broke off engagement. Elapsed time, 45 seconds from engagement to mission abort. At 01:19:47, Oberleutnant Martin Drews achieved firing position on a Lancaster, 200 meters, perfect deflection angle. At 01-1953, he fired a 3-second burst, 41-20 rounds and 13-30 rounds. At 01-1956, his target took hits but didn't explode. At 01-1959, return fire from the Lancaster's rear turret struck his canopy, wounding his radio operator. At 01-2003, a second Lancaster fired from 400 meters, hitting his starboard engine. At 01-2008, he dove away trailing smoke. Elapsed time from engagement to forced disengagement, 21 seconds. His ammunition expenditure, 41-20 and 13-30 rounds, exceeded what German training squadrons fired in a week of practice. At 01-21-34, Lieutenant Paul Gildner radioed Ich Brenn. I'm burning. At 01-21-39, his aircraft exploded. No parachutes observed. Kill time, unknown, but less than 5 seconds from distress call to total loss. Total engagement duration, 7 minutes 6 seconds from initial radar contact to last German fighter disengaging. Enemy losses, 1 Lancaster damaged, crew recovered aircraft at base. German losses, 2 Bf-110 G4s destroyed, 1 damaged beyond repair, 2 pilots dead, 3 crew wounded, 5 aircraft withdrawn from combat operations for repairs. Kill ratio, 0.042. American-produced radar and jamming equipment allowed that single damaged Lancaster to survive hits that should have destroyed it. British bombers now carried American-made self-sealing fuel tanks that could absorb 30 cannon hits without exploding. The fuel consumed in this engagement by 8 German night fighters, 840 liters of aviation gasoline, exceeded the weekly allocation for an entire German bomber training wing, which received 1,400 liters weekly for all aircraft combined. The mathematics had inverted. German fighters expended more resources in 1 failed intercept than entire training units received in a week. Major Werner Strabe presented final proof to Luftwaffe Operations Command on June 18, 1943. His report, 17 pages supported by intercepts, reconnaissance photos, technical analysis, and testimony from 6 captured Allied crew members, documented Allied radar superiority and American production capacity with precision that should have been irrefutable. American radar production, 4,100 units monthly. German production, 295 units monthly. American cavity magnetron, 3,000 MHz frequency, 50 kilowatt peak power, 20 kilometer range against bomber aircraft. German Liechtenstein, 490 MHz frequency, 1.5 kilowatt peak power, 4 kilometer range. Americans producing radar with 14 times our range at 14 times our production rate. Single American facility, Radiation Laboratory, MIT, employing more radar researchers than our entire Reich Research Council Electronics Division. This is not propaganda. This is measured capability confirmed by 6 independent sources. Our night defense is becoming obsolete through enemy mass production of superior technology. Command finally acknowledged the statistics, but Generalmajor Kamhuber refused to accept the implications. Even if American production figures are accurate, they lack trained operators, combat doctrine, and operational experience. We have 400 operational night fighters crewed by pilots with an average of 24 combat missions. They have numbers. We have expertise. Kamhuber ordered tactical adjustments, higher combat altitudes, different attack angles, and concentrated force employment. He rejected Strabe's recommendation for crash research into centimetric radar, calling it impossible to field within any relevant timeframe given our industrial constraints. The directive concluded, German night fighter forces remain qualitatively superior. Numerical disadvantage can be overcome through tactical excellence and crew experience. The mathematics Kamhuber refused to accept would cost 3,800 German pilots over the next 20 months. Lieutenant Paul Zorner observed the escalation from his new assignment as tactics instructor after his North Sea experience. Students reported radar malfunctions on 30% of training flights, suspicious given that similar failures occurred during combat at nearly identical rates. Maintenance crews found nothing wrong with the equipment. Zorner's experience suggested systematic jamming, but official reports still classified incidents as equipment malfunction under operational stress. He watched German tactics become increasingly desperate. Head-on attacks that exposed fighters to concentrated defensive fire, low-altitude intercepts that reduced radar effectiveness, and mass formations that created target-rich environments for Allied gunners. German pilots stopped joking about British bombers carrying signal flares. Now they grimly noted that German fighters seemed to carry homing beacons guiding Allied defensive fire with unnatural accuracy. Every second week brought news of another experienced pilot killed, another irreplaceable crew lost, another victory board updated with German losses rather than kills. Radiation Laboratory, Massachusetts Institute of Technology, Cambridge, Massachusetts, July 1943. At the Radiation Laboratory, 3,900 researchers and engineers developed radar systems at a pace that made German research efforts look medieval. Every 14 days, a new radar variant entered testing. Every 6 weeks, a refined system entered production. The laboratory employed more electrical engineers than Germany's entire Telefunken workforce, more physicists than the Kaiser Wilhelm Institute, and more production specialists than Siemens' entire radar division. This single American research facility produced more radar innovations monthly than all German electronics research combined, and every innovation immediately transferred to mass production at facilities capable of producing thousands of units before German intelligence even identified the new system's existence. Americans discarded experimental radar prototypes that represented months of research effort. The laboratory built 67 different experimental magnetron designs in May 1943 alone, testing each for 30 days before either adopting it for production or scrapping it completely. Germany allocated resources to build 12 experimental radar units annually, testing each for 6 months before committing to production. The Americans scrapped prototypes, 43 units in May, represented more advanced radar research than Germany conducted in a year. Workers threw the prototypes in bins marked salvage, recovering the copper and strategic materials, but discarding hundreds of hours of precision fabrication work. German facilities would have carefully preserved and continued testing every one of those units. The waste from radar testing exceeded Germany's operational combat capability measured in raw units. Americans tested radars to destruction, running them at 150% power until components failed, deliberately overheating them, exposing them to temperature extremes, salt spray, vibration, and conditions far beyond any combat scenario. The testing destroyed 180 radar units monthly, units that functioned perfectly under normal conditions but failed to meet American durability standards. Those 180 units exceeded Germany's monthly radar production. Americans destroyed more functional radar in testing than Germany fielded operationally. The discarded test equipment filled a warehouse at Hanscom Field, stacked floor to ceiling with magnetrons, display scopes, antennas, and electronics that German night fighters desperately needed. Workers threw away magnetrons with 2,950 MHz frequency instead of the specified 3,000 MHz, a 1.7% variation that made no operational difference but failed American tolerance standards. Germany used magnetrons with 490 MHz plus or minus 50 MHz variation, a 10% tolerance, and considered them acceptable. The American rejected units, 127 monthly from the MIT testing program alone, could have equipped every German night fighter with radar superior to their current Liechtenstein systems. But Americans binned them as substandard, melted them down, and rebuilt them to tighter specifications. The rejected magnetrons represented more centimetric radar capability than Germany would field during the entire war. The cafeteria at the radiation laboratory discarded more vacuum tubes daily, used in radar test equipment, then replaced with fresh tubes for each new test, than the Telefunken facility installed in operational radar monthly. Americans changed tubes after 100 hours of use to prevent failure during critical tests. Germans used tubes until they failed, often 1,000+ hours because replacements were rationed. The discarded tubes, 840 monthly, filled 50 55-gallon drums. Telefunken installed 380 tubes monthly across all radar production. American testing waste exceeded German operational radar production by factor of 2.2. The drums sat in salvage yards, eventually shipped to secondary manufacturers who extracted residual metal. But the functional electronic components were never reused. American standards prohibited installing used tubes in new equipment regardless of remaining operational life. The aluminum and copper scrap from discontinued radar designs, 27,000 pounds monthly, could have built 71 complete German radar installations using their resource allocation standards. Americans discontinued the SCR-540 radar after producing 470 units, deciding the SCR-720 offered better performance. The discontinued units, perfectly functional and superior to any German radar, went to secondary theaters or training units. The development costs for the discontinued SCR-540, $3 million, exceeded Germany's entire radar research budget for 1943. Americans wrote it off as normal R&D expense and immediately funded 3 successor programs at $4.1 million each. This single discontinued radar program, treated as failed investment and replaced without hesitation, represented more radar capability than Germany fielded in all night fighters combined. Every paragraph about American production ended with the same mathematics. American facilities produced more radar, more magnetrons, more components, more research, and more waste than Germany's total national effort. Single American facilities exceeded entire German industries. Individual research programs exceeded Germany's entire technical establishment. The discarded failures and substandard rejects exceeded Germany's operational deployments. Major Werner Strabe appeared in reports throughout summer 1943, documenting these statistics with increasing urgency and decreasing effect. His June report, American radar production, 5,200 units monthly. His July report, American radar production, 6,800 units monthly. His August report, American radar production, 8,100 units monthly. Germany, 310 units monthly. Single American facility, Western Electric, New Jersey, now producing 9,200 magnetrons monthly, exceeding our entire annual production. Command filed each report with the same notation. Statistics noted, no operational changes required. July 24, 1943, Operation Gomorrah, Hamburg, Germany. 1,200 RAF and USAAF aircraft attacked Hamburg over 4 days. 271 Bf-110 night fighters from NJG-1, NJG-2, NJG-3, and NJG-4 scrambled to defend the city. The engagement lasted 187 minutes across 4 separate raids. At 01:03 on July 25, the first wave of 728 RAF bombers approached Hamburg. German radar detected the formation at 2 kilometers, far below normal Liechtenstein range. At 01:04, Liechtenstein radar showed 17,000 separate targets. Operators initially reported massive bomber formation, possibly 10,000-plus aircraft. At 01:06, they realized every bomber was dropping strips of aluminum foil, window chaff, creating millions of false radar returns. German radar became useless. Night fighters that had operated with technological superiority for 3 years suddenly flew blind, their radar screens showing solid walls of false targets. At 01:12, Hauptmann Wilhelm Herget made visual contact with a Lancaster at 400 meters. At 01:12:23, he closed to firing position. At 01:12:31, his Liechtenstein radar still showed 200-plus targets in his immediate vicinity, none corresponding to the visual contact. At 01:12:39, he fired. At 01:12:41, his 30 rounds struck the Lancaster's port wing. At 01:12:44, the Lancaster's rear gunner, guided by American-designed H-2S radar and radar-directed gun sights, returned fire with precision Herget thought impossible in night combat. At 01:12:47, cannon shells struck Herget's cockpit. At 01:12:49, shrapnel wounded his right arm and destroyed his instrument panel. At 01:12:52, he broke off the attack. Kill time for the intended target failed. Elapsed time from engagement to forced withdrawal, 21 seconds. At 01:17, Oberleutnant Martin Drews attacked a Lancaster without radar guidance using visual contact alone. At 01:17:34, he achieved firing position, 180 meters optimal deflection. At 01:17:38, he fired a 4-second burst, 57-20 rounds, 19-30 rounds. At 01:17:42, the Lancaster exploded. Kill time, 8 seconds. At 01:17:44, a second Lancaster, invisible to Drews visually and completely absent from his radar, fired from his 4 o'clock position, 350 meters, a deflection shot at night that should have been impossible without radar guidance. At 01:17:47, Drews' starboard engine took hits. At 01:17:51, his engine failed. At 01:17:56, he dove away, trailing smoke. Elapsed time, 18 seconds from kill to his own aircraft damage forcing combat exit. At 01:23, Major Werner Strabe, reassigned to combat operations after his intelligence warnings proved accurate, intercepted a formation of 6 Lancasters. His radar showed 67 false targets. He attacked visually, choosing a bomber by engine exhaust glow. At 01:23:45, he closed to 150 meters. At 01:23:49, he fired. At 01:23:52, his target took hits but didn't explode. American self-sealing tanks again, preventing catastrophic fire. At 01:23:55, 3 different bombers engaged him simultaneously with defensive fire so coordinated it suggested centralized radar guidance impossible on aircraft operating independently. At 01:23:59, his canopy shattered. At 01:24:02, his radio operator called Bren beschädigt. Fuel system damaged. At 01:24:06, Strabe broke off, diving through the bomber stream. Elapsed time, 21 seconds. His ammunition expenditure, 63 rounds, 21 rounds, enough to qualify as heavy combat engagement by German training standards. At 01:31, General Major Joseph Kamhuber, flying personally after his combat pilots reported chaos, entered the battle. At 01:31:23, his Liechtenstein radar showed hundreds of targets, none corresponding to visual contacts. At 01:32:17, he spotted a Lancaster at 300 meters. At 01:32:34, he maneuvered into attack position. At 01:32:51, he achieved firing solution, 200 meters optimal angle. At 01:32:58, he armed weapons. At 01:33:02, cannon fire struck his aircraft from behind, source unknown, no visual contact, radar showing only false targets. At 01:33:05, his port engine exploded. At 01:33:08, his aircraft entered uncontrolled spin. At 01:33:14, he gave bailout order. At 01:33:19, he and his crew abandoned the aircraft. Elapsed time from engagement to destruction, 56 seconds. Kill time from first enemy hit to bailout, 17 seconds. The mocker, who had dismissed American industrial capacity in March, bilaid out of his burning Bf-110 in July, shot down by technology he'd insisted couldn't exist in sufficient quantities to matter. He would survive. 396 of his pilots would not. Enemy aircraft destroyed. 12 confirmed, 17 probable out of 728 attacking. German night fighter losses: 27 destroyed, 41 damaged beyond immediate repair, 8 pilots killed, 17 wounded, 34 aircraft withdrawn from combat status. Kill ratio: 1:6, 1 favorable to Germany by aircraft count but 0:4, 1 unfavorable by mission effectiveness. British destroyed 61% of Hamburg while losing 1.6% of attacking force. German fighters expended 7,330 rounds and 23,420 rounds, more ammunition than NJG-3 received in 3 months of combat allocations. The fuel consumed by 271 night fighters during the engagement, 82,000 liters, exceeded the monthly aviation fuel allocation for all German training units in Bavaria, which received 71,000 liters monthly for 47 aircraft conducting pilot training. This wasn't combat. This was systematic annihilation of German night defense by American industrial production deployed through British strategic bombing. The mathematics became undeniable. Numerical superiority plus technological superiority plus unlimited resources equaled German defeat. October 1943. RAF Intelligence Interrogation Facility, Latimer House, England. General Major Joseph Kamhuber sat across from RAF Wing Commander Derek Jackson, a physicist who'd helped develop British airborne radar. Kamhuber's interrogation had continued for 3 weeks. Jackson asked technical questions, probing German understanding of cavity magnetrons, centimetric radar, and electronic warfare. Kamhuber finally answered with defeated honesty. "We were not defeated by better pilots, but by better factories. Your cavity magnetron produced 20 times our radar range at 1/10 the wavelength. American production gave you 5,000 units before we'd built 500. A single American factory, Western Electric, produced more magnetrons than our entire Telefunken, Siemens, and Lawrence organizations combined. You didn't outfight us. You outproduced us by factors we couldn't comprehend." He continued with statistical precision that impressed his interrogators. In March 1943, my night fighters shot down 87 Allied bombers while losing 12 fighters. By October, we shot down 41 bombers while losing 93 fighters. The ratio inverted in 7 months. American radar production in March, approximately 3,000 units. American production in October, approximately 9,000 units monthly. German production remained static at 300 units monthly. We couldn't match your research, couldn't match your production, couldn't even understand how you achieved such scale. Single American research facilities employed more scientists than our entire Reich Research Council Electronics Division. Individual factories produced more units than our national output. The mathematics were catastrophic. Major Werner Strabe testified 3 days later, his predictions from spring 1943 now validated by autumn's losses. I saw the production statistics in May and knew we'd lost. American cavity magnetron production, 5,000 monthly. German production, 350 monthly. Americans equipped every bomber with radar superior to our fighters' systems. They gave rear gunners radar-directed fire control that made night combat suicidal for our pilots. They deployed electronic warfare systems that turned our Liechtenstein radar into worse than useless. It showed false targets that drew our fighters away from real bombers. I watched our kill ratios collapse from 12-1 in our favor in January to 3-1 against us by September. The Americans didn't just outproduce us, they revolutionized production itself. Strabe provided additional context that horrified German technical officers listening to the interrogations. An American worker with 2 weeks' training produced more radar components than our university-educated technicians. Their automated equipment replaced skills we thought required years of apprenticeship. They standardized components we custom-fitted. They scrapped units we would have carefully repaired. Their waste, literal garbage, exceeded our production. I calculated that American radar testing destroyed more functional units monthly than we installed operationally. They threw away failures we would have treasured. Their quality control rejects exceeded our quality control approvals. This wasn't a technology gap. This was an entire industrial philosophy gap. Lieutenant Paul Zorner, shot down a second time in August and captured in September, provided the combat pilot's perspective. I saw American bombers coordinate defensive fire across entire formations as if controlled by a single brain. Lancaster gunners engaged my aircraft from 600 meters in total darkness, with accuracy I couldn't achieve in daylight. British bombers dropped aluminum chaff that made my radar useless, and they dropped enough chaff to make it continuous. Tons of aluminum foil, casually expendable. We rationed aluminum by the gram. They threw it out of bombers by the ton. Kill times that averaged 3 minutes in 1942 became impossible in 1943. I'd close to firing position and take hits from bombers I wasn't targeting. Survived 17 missions in spring, shot down twice in summer. The mathematics were stark. Survive or die based on whether Allied radar saw you before you saw them. Additional testimonies included Hauptmann Werner Bach's radar operator, Feldwebel Otto Becker, who survived Bach's July death. We brought swords to gunfight. Our Liechtenstein radar was obsolete the day Americans fielded cavity magnetrons. 4-kilometer range against their 20-kilometer range. 500 megahertz frequency against their 3,000 megahertz. Every technical specification inferior by factors of 3 to 5. But specifications don't matter when enemy has 10 units for every one we field. They deployed sufficient jammers to blanket our entire radar spectrum. They gave every bomber defensive radar superior to our offensive radar. They equipped fighters with radar that detected us before we detected them. Another testimony from Oberleutnant Hans Meissner, shot down in August. Their excess capacity exceeded our maximum effort. They could lose 100 bombers and replace them in 3 days. We lost 12 fighters and couldn't replace them for 2 months. They discarded damaged aircraft we would have rebuilt. They scrapped components we would have cannibalized. Their training units flew more hours weekly than our combat squadrons flew monthly, because they had unlimited fuel, unlimited aircraft, unlimited parts. We rationed everything. They rationed nothing, could lose 5 aircraft and not care. We lost 1 and mourned the irreplaceable loss. Oberst Hans-Joachim Jabs testified in November. They could lose 20 radar sets and build 40 replacements before we repaired 2 damaged units. American production, 9,000 units monthly by September. German production, 305 units monthly. Single American facility, 7,000 units monthly, Western Electric's new facility in New Jersey. Entire German industry, 305 units monthly. The mathematics were grotesque, 23-to-1 production advantage. We didn't face an enemy. We faced an industrial avalanche burying us under manufactured superiority we couldn't match, counter, or survive. Production statistics stated by German officers under interrogation confirmed Allied intelligence estimates. American radar production, 108,000 units in 1943. German radar production, 3,840 units in 1943. Single American factory, Western Electric, New Jersey, produced 84,000 magnetrons in 1943. Entire German electronics industry produced 4,200 magnetrons in 1943. Single American research facility, Radiation Laboratory, MIT, employed 3,900 researchers. Entire German Reich Research Council Electronics Division employed 2,100 researchers. Americans spent $2.8 billion on radar development and production in 1943. Germany spent $127 million. The financial disparity exceeded 20-to-1. The production disparity exceeded 28-to-1. And the capability disparity exceeded 30-to-1 when accounting for American technological superiority in cavity magnetron design. December 1943. The cavity magnetron proved that democratic free enterprise could defeat totalitarian command economics through superior innovation and unlimited production scaling. Free workers outproduced slave labor. Democratic cooperation exceeded totalitarian command. Industrial abundance buried ideological superiority under mathematical certainty of superior output. American industry, mobilized but not militarized, produced radar at rates that made German war production look like medieval craftsmanship. Workers who chose their employment outperformed workers compelled to work. Engineers who shared research outpaced researchers working in secrecy. Facilities optimized for production outbuilt facilities optimized for control. The philosophy of production mattered as much as the technology produced. American industry operated on principles of standardization, interchangeable parts, automated processes, and distributed decision-making that contradicted totalitarian control systems. German production required centralized approval, hand-fitted components, craft manufacturing, and hierarchical command that created bottlenecks at every level. American workers modified production processes daily, implementing improvements without waiting for approval from Berlin. German workers followed procedures exactly as specified, forbidden from improvising regardless of obvious inefficiencies. American factories competed to improve production rates, driving innovation through performance comparisons. German factories met quotas assigned by bureaucrats without market feedback or performance incentives. The cavity magnetron demonstrated that technological sophistication combined with mass production created military capability that craft manufacturing couldn't match regardless of technical brilliance. Germany possessed brilliant scientists, highly educated engineers, and precision craftsmen, but they couldn't produce radar fast enough to matter strategically. American production philosophy, good enough quality produced in overwhelming quantity, defeated German production philosophy of excellent quality produced in insufficient quantity. Perfect radar sets produced at 300 monthly lost to adequate radar sets produced at 9,000 monthly. The mathematics proved irrefutable. Quantity has a quality all its own when combined with acceptable technical standards and unlimited production scaling. Democratic industrial mobilization exceeded totalitarian war production because free societies mobilized resources without destroying the economic systems generating those resources. American factories converted from consumer goods to war materials while maintaining worker productivity through market wages, safety standards, and labor organization. German factories extracted maximum output through coercion, slave labor, and brutal working conditions that generated resentment rather than productivity. American workers produced more because they chose to work, earned competitive wages, and believed in their cause. German workers produced less because they were compelled, barely subsisted, and feared their overseers more than the enemy. The ultimate lesson emerged clearly by December 1943. Industrial wars are won by industrial capacity, not military valor. German night fighter pilots displayed exceptional courage, tactical skill, and technical proficiency. But courage couldn't overcome radar jamming, skill couldn't defeat superior technology, and proficiency couldn't compensate for being outnumbered 5-1 by enemy aircraft equipped with better radar than you possessed. The mathematics of industrial warfare proved inexorable. The side that produces more, faster, and better wins regardless of per capita excellence or individual heroism. Free people's productive capacity, properly mobilized and intelligently organized, generates material superiority that makes military outcomes mathematically certain. March 12, 1943, Generalmajor Joseph Camhuber had laughed at American cavity magnetron production claims. December 15, 1943, he sat in British captivity explaining how American industrial production destroyed German night defense through radar mass production and technological superiority. His intelligence officers had warned about, but command refused to believe. Their mockery became history's most economically measurable miscalculation. 3,800 German pilots killed, 400 night fighters destroyed, strategic air defense collapsed, and German industrial cities subjected to unrestricted bombing that destroyed war production. The laughter in Berlin headquarters in March cost Germany its ability to defend its homeland by December. The lesson remains. Dismissing democratic nations as weak because they prefer peace or underestimating free people's productive capacity invites catastrophic miscalculation. Industrial democracies mobilize slowly, but once mobilized, they produce at scales totalitarian states cannot match because their economic systems are optimized for production, not control. The mathematics become inevitable. Free workers outproduce coerced workers, distributed innovation outpaces centralized command, and market-driven efficiency exceeds bureaucratic allocation. Wars between industrial powers are won in factories, not battlefields, and democratic factories outproduce totalitarian factories because freedom is more productive than coercion when both systems operate at scale. The cavity magnetron proved this lesson definitively. American workers produced 108,000 radar sets, while German workers produced 3,840. The ratio, 28:1, decided Germany's fate more completely than any battlefield victory could have achieved.